In the second half of section 9.6, we will be classifying conic sections. And remember, those conic sections are where two cones are inverted and a plane has sliced those. So you'll either get a circle or an ellipse or a parabola or a hyperbola. All right, so the first thing we need to be able to do is we need to be able to look at their standard forms and recognize, well, what shape do we have? So you should be able to recognize that if you've got a perfect square binomial plus a perfect square binomial equals some number, then this is going to be a circle. You should be able to recognize that. And you may be able to, and you may say, well, what happens if, because we could divide this by 4 and have it equal to 1, and what if it's an ellipse? The reason you can tell, the way you can tell the difference is that if the numbers underneath your perfect square are the same, then that means that that distance from the center of the shape to the edges is the same. Therefore, it is a circle. So this is a circle. Because this is a squared term minus a squared term equal to 1, this would be a hyperbola. Are you recognizing them? This one has one squared term, and the y is not squared. So therefore, if the x term is squared, this is a parabola. And I should back up and say, okay, a circle. We have a circle with the center at -5, 1, and a circle is just a circle. The hyperbola, you've got the x squared term is first, so these are going to open to the edges, so it's going to open this direction. The parabola, because it's the x squared term, it's going to open either up or down, and because this term is positive, it's going to open up. And this one, because you've got a squared term plus a squared term equals 1, this one is an ellipse. And you should, and did I spell that right? Who knows? You should be able to recognize those now when they're in their standard form. Also, you can look to see the y term, the number under the y term is larger. Therefore, this is an ellipse that is long. Oops, that's not the y direction. It's longer the y direction. So it's going to be an up and down ellipse. Now, what I've asked you now, the next thing I want you to do is not only do you need to be able to recognize what shape do you have, I'm asking you, what are the lines of symmetry in each of these? Now, if you've got, in this case, you've got a circle, excuse me, you've got a circle, and your center is at -5, +1. So right about there, and the radius is 2. So you've got, oh, that's just not even near the center, but there's the idea. You've got a circle with the center at -5, 1. The lines of symmetry of a circle, there's infinite number of lines of symmetry. So in this case, the lines of symmetry for this circle are any lines that's going to pass through the center. So your answer would be any line passing through the point -5, 1. So that is, so you've got many lines of symmetry in that one. With a hyperbola, you've got 2 lines of symmetry, because you can either fold it this way and then cut your 2 parabolas, your hyperbola, in half this direction, or you can fold it this way and fold it back on itself. So in this case, you've got a hyperbola. The center of that hyperbola is -2, +1. So the center is here, and then it's going to open. These 2 directions. So you can know, no matter how wide or long or wherever those are, you can know that there's going to be a line of symmetry that runs straight through the hyperbola that direction. So either or straight up and down like this. So either x is going to equal -2, or y is going to equal 1. So here you see If your x is -2, your y is anything. So that's this vertical line. X is -2 is one line of symmetry. That will fold these two up onto themselves. Or y equals 1. So y is 1 up anywhere on this line. Anytime y equals 1, it doesn't matter what x is. Y equals 1 is going to be this horizontal line that will then fold the two parts of each of the two parts of the hyperbola on themselves. So the lines of symmetry, there are two lines of symmetry for a hyperbola. And it's going to be your x, the point that passes through the center vertically and horizontally. All right. So on a circle, you've got infinite number. On a hyperbola, you're going to have 2. On a parabola, because this is going to open up and down, and the center is going to be negative here. Let's look at it again here. The center is going to be 4 and -2, and it's going to open up and down. So this is going to be a vertical line at x equals 4. So for your parabola, it's going to be whatever your squared term is. You're only going to have one line of symmetry for a parabola. You can only fold it in half this way. If you've got a y squared term and your parabola is going right or left, then you're going to have a horizontal line. So you're going to have y equals whatever your center is, whatever the y value is at your center. Okay, so for the parabola, you're going to have one line of symmetry, and that's going to be the value that runs right through the center of your parabola. So if it's an up and down, it's going to be an x value, so it's going to be a horizontal, vertical line. And if it's a right or left, a horizontal parabola, then it's going to be y equals whatever that center is of that parabola that way. All right, and your last one is an ellipse, and you can see that in an ellipse you'll also have two lines of symmetry. You're going to have two, and those are also going to go right through the center. So this one is +3, +2 is going to be your center here, and you're going to go right and left 2 and up and down square root of 13. So it's going to be something like this. Oh wow, not even close, but you get the idea. You know what we're doing. Okay. I've seen some of your homework pages though, so I know that mine is even better than yours. Ha! So your lines of symmetry are going to be the horizontal and vertical line that go through the center of your ellipse. So it's going to be x equals 3 and y equals 2. Those are your two lines of symmetry that are going to go through the center. So your center point is going to be your point of reference for those lines of symmetry. Okay, let's move on then to something more difficult. If you've got, so these were all written in, they've all been nice and neatly written in their standard format so that we could quickly and easily identify what shape they are. Well, if you don't have the standard form, then what you're going to end up with is all of these x squares and y squares. And so ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0 is the form of any quadratic or any conic section. So all of these equations could be put into this format. So how do we know what shape we have, what quadratic we have, simply by looking at this? Well, we're going to use the discriminant. The discriminant is b squared minus 4ac. It's just like when we did simple quadratics and they didn't have x's and y's. All right. So the discriminant is b squared minus 4ac. Now, if you work that discriminant, and that discriminant is less than 0, and your b is equal to 0, and your a and c are equal, then that's going to be a circle. This is something that you should put into your notes. I shouldn't have to tell you these things. This needs to be in your notes. You're going to need to have this. All right? This would be a wise thing to have on your note card for a test, possibly. That was like a monster huge hint, right? All right, if your discriminant is less than 0 and either b is not equal to 0 or the a and the c are not equal, then you actually have an ellipse. If you work this discriminant and it's equal to 0, then you have a parabola. If you work this discriminant and your answer is greater than 0, then you have a hyperbola. So what we're going to want to do then with this information is we want to classify. We're going to look at an equation, and let me give you one here. While you're writing that down, I'm going to give you a problem. Whoops, 9x squared plus 4y squared minus 36x minus 24y plus 36 equals 0. All right, so we have this big old long equation. The step one is to find out, well, what on earth shape do we have? We can do that by working out the discriminant. So the discriminant was b squared minus 4ac. So we find the b. The b is the xy value. And in this equation, there is no xy value. So we have 0 minus 4 times a. A is the x squared coefficient, so 9, times c, which is the y squared coefficient, and that's 4. So negative 4 times 9 is 36. You know what? I didn't do this before. And then 36 times 4, 6 times 4 is 24, 12, 34, 144. So my discriminant is 144. Uh-oh, but it's negative 144. And you know what? That's why I didn't work it all up before, because I said, oh, negative times a positive, that's negative. I don't even care what the value is. If it's negative, it's less than 0. So that's why I didn't do it. Haha, now you know my secret. Okay, so if it's less than 0, it's either a circle or an ellipse. And b is equal to 0. Sure enough, b was 0, so it could be a circle. But a and c are not equal. So we know right away that this is an ellipse. So that's your first answer is, what is it? It's an ellipse. So then what we're going to do, what I'm going to ask you to do next is not only classify that, I want you to determine what it is, then I'm going to want you to graph that ellipse. In order to graph the ellipse, or whatever shape, you've got to put it into the standard form of that shape. And if you'll remember, the standard form of the ellipse is going to be the x squared over a squared plus y squared over b squared equals 1, right? So what we're going to need to do is we're going to need to group together the x's and the y's, and we're going to need perfect squares. So with these problems, you're going to do a lot of completing the squares. So I hope you remember how to do that. So first, let's group together our x's and y's. So we've got 9x squared minus 36x, and then we're going to put the 4y squared minus 24y. And what I'm going to do is I'm going to get rid of this 36, not get rid of it, but move it to the other side of the equation. And when I do that, I'm going to subtract it so it becomes a negative 36. All right? Now what I want to do is I want to complete each of these squares so that I have a perfect square in each one of those. All right? So, and what I'm doing is I'm manipulating these numbers and terms so that they look like this format. This is what I'm aiming toward. All right? So the first thing is I want the x squared term to not have a coefficient. So first we're going to factor out the 9. So we have 9. And then inside we have x squared minus, I'm going to take the 9 out of here too, so 4x. So I've got x squared minus 4x, and this is where I'm going to complete the square. So x squared minus 4x, and if you'll remember to complete the square, you might need to write down some notes if you don't remember, you're going to take half of this middle coefficient and then square it. So half of 4 is 2, and 2 squared is 4, so you're going to add 4. Now, when you do this, what you've actually added is not 4, but 4 times 9. So you've added 36. So on the other side of your equation, so we already have negative 36. On the other side of the equation, we're going to add 36. because we added 36 here. See what we're doing? Then we're going to pull the 4 out of here, factor 4 out of our y values, our y terms, and so that we end up with a y squared without a coefficient, y squared minus, and we took 4 out of here, so this is going to be 6y. And now we want to complete this square as well. So half of 6 is 3, and 3 squared is 9, so we're going to add 9. And remember, we're not going to add 9 to the other side. We're going to add 9 times the 4. So we're going to add another 36. So now what we have is, we have 9 times x minus 2 squared plus 4 times y minus 3 squared equals 36. Do you see where I got those parts? I factored this down to y minus 2 squared. I factored this down to y minus 3 squared. And this is negative 36 and positive 36 cancel each other out. So I just have 36 left here on this side of the equation. Now I want my equation to be equal to 1. We're almost there. I want my equation to be equal to 1. So divide by 36. I can do that as long as I divide everything in the entire equation by 36. And when I do that, this reduces down to 4. This reduces down to 9. So I have x minus 2 quantity squared over 4 plus y minus 3 quantity squared over 9 equals 1. And now remember, this is, you want this to be, in order to graph it, we need to know what the square is. So this is 2 squared, and this is 3 squared. So now to graph, we're simply going to put the center of our ellipse is going to be 2, 3. So 1, 2, and 1, 2, 3. So there's the center of our ellipse. And then the x direction, we're going to go right and left, 2. So 1, 2, there's our one of our vertices and another vertice. Actually, these are the co-vertices because they're shorter. And then 3 up and down, 1, 2, 3, and 1, 2, 3. And then you're simply going to connect the dots in a lovely smooth ellipse. Okay, it's a little bit pointy, but that's okay. That's all there is to it. Once you get to this point, it's exactly what you've done, and it's just graphing them. And all I've done is the ellipse. So you'll possibly have a circle, you'll possibly have a hyperbola, possibly the parabola is going to be the easiest to recognize because it's not going to have, it'll only have one squared term, one or the other. All right? So, a lot of completing the square. If you don't remember how to do that, you might want to look back and see where we discussed that before, or watch again, go back in this video and watch again, or ask me in class, or all of the above. And I think that's all we have for today. Good luck. I'll see you soon.